Hello and welcome back to the lecture series MATLAB Essential for Scholars, Scientists and Engineers. I am Dr. Merchant, and in today's session we will begin exploring the fundamental building blocks of MATLAB programming, basic operations and arithmetic. MATLAB is built around matrix and arrays mathematics, which means that performing arithmetic operations is not only straightforward like using a calculator, but also powerful due to its support for vectorized computation. Whether you are dealing with single value or large data set, MATLAB handles them seamlessly using concise and efficient syntax. In this lecture, we will cover basic arithmetic operation, element-wise operations, and key mathematical functions, all with the clear examples to help you build a strong foundation for further learning. So let's dive into the world of number, matrices and operations and see how the MATLAB makes computation both intuitive and powerful. So these are some basic operations you can see here: addition, subtraction, multiplication. So here are the basic operations: addition, subtraction, multiplication and division. For addition we are using the plus sign, and for the subtraction we can use minus, and for the multiplication we can use this product sign, and backslash is used for division, and this symbol is used for the exponent. For example, you can see in the third column 5 plus 3 will be 8, and after computing the value will be stored inside A, so the output will be A is equal to 8. Similarly, for the subtraction we can use 10 minus 4, and the value after computing will be stored inside B, and the output will be equal to B. Similarly, for the product we are using 6 product 7, which is 47. After computing the value will be stored inside C, and the output will be equal to 42. And for the division we have 20 upon 4, which will be D is equal to 5 as output, and this is the exponent 2 raised to power 3. The meaning is that 2 cube, and we know the value of 2 cube will be equal to 8, and that's why we have is A is equal to 8. Here we have some element wise operations, and these are very important to consider here, and each must be very clear. So here you can see that when we have two arrays and we want to multiply these two arrays element wise element, in that case we have to use dot product. See here, this is the example. This is the first array, this is the second array, and we want element wise element multiplication. So in that case, when you will use this symbol, this will return 1 into 4, 2 into 5, 3 into 6. Okay, so 1 into 4 will be equal to 4, and 2 multiplication with 5 will be 10. Similarly, 3 multiplication 6 will be equal to 18. And in the same way, if we have element wise division, we are using this symbol, and this is the first array, this is the second array. We want to divide 10 by 2. The meaning is that when we will divide the element wise division, in that case this is the first element and this is the first element. This element will be divided by 2, and second element here is 4. 20 is divided by 4, and 30 is divided by 5. So the values after division we will get a new array that will be 5, 5 and 6. Similarly, if we have element wise power, and for that we are using dot cap. Okay, so the meaning of this one is 2 raised to power 2, and 3 raised to power 2, 4 raised to power 2, and after computing all these values we will have 4, 9, 16 after computing all these values. Okay, so these are the difference between the simple product, addition, element wise division, element wise multiplication, and element wise power. Now these are some inbuilt predefined functions which are available in the MATLAB. Okay, so sqrt means square root, and this is the input argument. So square root of a number is computed by using this inbuilt function. Square root, this will be equal to 4. Similarly, if you need natural logarithm, we will use log 10. Okay, so this is the log 10 of log of the value 10, And similarly exponential 1 we can get absolute value of -7, and for the round value we are using round function 3.7. okay, so this will return about 7. And there are so many inbuilt functions in the MATLAB inside. By using help function we can get the detail of all the elementary functions which are inbuilt inside the MATLAB. So now we will do all these basic operations by using the MATLAB. Okay, so see here, this is the MATLAB window, and here we will discuss all the elementary operations. So here suppose that we have a is equal to 9 and use the semicolon to store the value. For the another value b is equal to I have is 16, use semicolon to suppress the value. And c is equal to I have is 56, semicolon. Then d is equal to I have 8, 9. So I have chosen here 4 parameters and their values. When I will enter, okay, so you can see in the workspace all the values has been stored, and in the first column you can see these are the variable and these are the values. Okay, now we will perform some operations. If you want to add, then add will be a plus b. So this will return the sum of these two numbers, 9 plus 16, and when you will enter, this is the output. Similarly, if you want subtraction, I am using here sub function. Okay, so this is the only just the assignment variable I am using for the subtraction. And if you are using here c minus b, so the meaning is that 56 minus 16, after computing the value will be stored inside sub. If you are using semicolon, okay, and you can see the value is stored in the workspace, which is 40. And if you want to display the value, you can use display function here, and you can pass sub function, okay, and then enter. So this is the output value of this c minus b. Similarly, if you want to multiply any number, and I am using here multi means multiplication of any two number or three number. I am choosing here C product D product A. Okay, so I am taking these three number, and when I will enter, you can see that this is the output value and this is the input value. Okay, here the values of C, D, A are there. The value of C is 56, that of D is 89, and that of A is 9. So after multiplying, this is the output value. And if you want to divide, in that case we have, for the division you can use C backslash B. Okay, so I am using C and B. C is divided by B, and after simplifying, you can see that this is the output value. If you want to check the exponent, for that what we do, expo is equal to, I am taking here a exponent 2, and when I will enter, this will return 81. The value of a we have is 9. So the meaning of this one is a square, which is 81. Okay, then after we can have element wise operations. I am using here CLC, and you can see that the command window is very clear. And if you are using here this percentage sign, this is the only comment. Okay, so here we are using some element wise operations. Okay, so for that what I do, we can take a x is equal to, I have is array, and the element inside the array I have is 1, 2, 3. Okay, and you can take some more element 4, and the other array I have is y, but the number of the element inside x and y both must be equal. Keep in mind, so that when we multiply, this can be 2. So here inside y we have is 3, 4, 5, 6. So x and y both have same length of element, and which is 4. So each x and y array contain 4 element. Now we will perform some operations. If we want to multiply x array with y. So what we do, x, if I will do directly x product y, this will return some error. Okay, you can see this is the error, and also you can see error is of this operation, and we can use here, check it, we have to use this operation. Okay, so I press upward arrow sign. When you will use upward arrow sign, this will return the previous statement, and for the correction I have to use at this place dot. So now this will return the element wise multiplication. Okay, so if you want to check the multiplication of these two operations, you can see here x is there and y is there, and the multiplication of these two is, this is the answer, this is the answer, ans. So this is the multiplication of these two arrays. Okay, or you can use here display function, display, here is x dot product y, you can use in this way also. So this is the value. Okay, so here is the product of these two, and this is the output. Similarly, if you need element wise division, what we are doing now, element wise division. Okay, so for that what we do, we can do like x dot y, x dot backslash y. So this will return element wise division. So these are the values. Another way to use the same, we can use display function, display, and inside we will apply the operation x dot backslash y, and then enter. So you can see this is the operation, element wise division. The element of x are divided by y, and these are the output values. Okay, so first element will be divided by the first element of the y, and second element of x will be divided by second element of y. Similarly, the third element of x will be divided by third element of y. So this type of the operation is known as element wise division. If you want to check the element wise power, okay, next we have is the element wise power. Okay, so for this we can have like x is equal to, we can take one array, and inside we have is 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9. These are the element of this one. Okay, now if you take x dot exponent 2, in that case all the element will be squared. Okay, one multiplication of 1 by 1, or you can say 1 square is 1, 2 square we have is 4, 3 square we have is 9, 4 square we have is 16, and so on. If you are taking is x dot exponent 3, so all the element of x are cubed, you can see here. Similarly, if you are using x dot exponent and the value is 0.5, okay, so the value of 0.5 means square root. So these are the square root of this array. Each element is the power 1 by 2, and after computing the values are available at this place. Okay, now there are so many elementary functions which are available inside MATLAB, and we can use these inbuilt functions directly. So CLC is used to clear the command window, clear is used for the clear workspace. Okay, and yes, now what we do, if you want to take square root of any number, then you will use sqrt, and I am taking it as place 25, square root of 25, square root of 25. Okay, and then enter. And if you want to take square root of any number, I have like 37. Okay, and then enter. So for the square root you can use sqrt. For log you can use here log 10. This is the natural log. Okay, is equal to 2.3026, and you can use log e. Okay, log e, and when you will enter, okay, the value is unrecognized. So what you will do, and the value of e you can use exponential. Okay, log, then here is exp1 and then enter. Okay, so log exponential 1 is equal to 1, both are opposite, and for exponential you can use direct exponential 1. Okay, so this is the value 2.7183. If you want to use absolute function, then you will use abs, and minus 7 will be equal to 7. And for the round function we have you can take 3.7, so this will be round up is 4. If you are taking about 3.2, then this will be equal to 3. So in this way you can use the round function. Now the thing is, there are so many elementary functions inside the MATLAB, and we must have information about all these functions which are available inside the MATLAB, how we can extract all these functions and how we can use. So what I will do, I will let you know the help elementary function. Okay, so this is the statement which I am using here. Note this statement: when you will use help elementary function, okay, you can use this, will return the details about all the inbuilt elementary functions. Okay, and when you will enter, you can see within a few seconds this will return all the elementary functions which are inbuilt inside the MATLAB, and starting from the trigonometric functions. So trigonometric, hypertrigonometric, inverse trigonometric, all the functions are available here. Then you can see the all type of the exponential functions are here. Okay, and then you can see complex functions, variables, how we can find out the absolute value, phase, angle, construct complex data, and many more. And at the end we have the rounding and remainder functions are here. So everyone who is want to use this MATLAB for computing whatever, for the class purpose, for the research, the most important thing is you must be familiar about all these inbuilt functions. So how you can learn, how you can use, what are the syntax. So before using, you must check the syntax of each elementary functions. So I will give you here, I will present only one example for you. Rest you will try all these elementary functions before using your purpose. Okay, so see here what I am doing. Press at this place. When you will click on sign, okay, similarly you can check all the functions. So as soon I will click at this place and come back here, this is the detail about the sine function. So here sine of the argument in radians, and this is the syntax how we can use is the sine of the element of x. Okay, and when you will use here sine 90 degree, sine 90. Okay, and you can see that the value for sine 90 is 0.8940, but this is not the value of 90 degree, this is the 90 radian. Okay, if you want to check for degree, come here, sine d, click here. Okay, see and go through the detail. Sine d, the argument in degrees, and this is the syntax how you can use. Okay, so all the details about how you can use sine d is available here. And when you will put here sine d and pass the value 90, and you will see that now the value is equal to 1. So this is the difference between sine radian and sine degree. So in the same way you can go through about all the details which are available here, and you must try all these. Okay, now all these we can create the script file, you can manipulate them, and to create the script file, what you will do, I am doing here CLC and clear. So now you can see that workspace and command window both are clear. Okay, so now if you want to create a script file, control N. Okay, and new editor file will open when you will use control N. Okay, so here you can save this file with the name of basic operation, with the name of basic operations. Okay, and then enter. Now I let you know how you can create this script file, and in this way you can create all type of the script file, but this is the first file for this session, so that I have to explain everything one by one. When you will use double percentage, here you can give the title, and we are doing for the basic MATLAB operations. Okay, so first we have is the addition. You can take the example, a is equal to I have is 9, and then b is equal to I have is 8, c is equal to I have is 3, and d is equal to I have is 6. So I have these values. Now for the addition is equal to I have a plus b plus c plus d. Okay, and suppress it, and for the display you will use display function. Here you will pass the argument a d d. Now you can see we have a very small program at this place for the addition. The values we are taking here a b c d, and here we have add is equal to a plus b plus d. Okay, this operation is applied, and after computing the values will be stored inside here, and this argument we are passing through display function. So when you will execute this sequence of the statement, the output will appear in the command window. Okay, see, so this is the output value. Also when you will write the script file, you can use here CLC clear. Okay, and see, now the only output value is there. So whenever you will execute the sequence of the statement and you are using the CLC clear, and these are the values which you store at this place, and this will print the value. So only the output value will be in the command window. Okay, so again we can use for subtraction. We are using here for subtraction. Okay, sub is equal to we have to take the values again from this place. We are taking the same value. Okay, and the subtraction also, you can see when we are using the double percentage sign, the file is divided into the slices. So this is the first section, this is the second section. Okay, so by using in this way we can divide the one file in the subsection, so that accordingly which section we need to execute we can do accordingly. So here this is the subtraction. I am using sub function, and b minus a I am doing here, b minus a, and to display you can use display function and sub. Okay, and when you will execute, if you want to execute only this section, then you will press here. See carefully, I am going to press at the place, and only this section will run, and the value is -1, but the previous value is there. So what you will do, CLC and clear. Okay, so run again from this place, only the value of this section is there. Okay, if your cursor is at this place, only this part will execute. See, now the value is 26. If your cursor is at this place, only this section will run. Okay, see, -1. Similarly, you can write for production, multiplication, division. Okay, I am doing here for multiplication. So here I am using the same values, and use here also CLC clear. Okay, so now here I am taking the multi is the only just assignment variable, and we are doing here a product, b product, c, use semicolon, and then display the value. We are using here display function and multi. Okay, and then we need to execute only this section. So your cursor is at the place, click here, so it is showing, okay, this must be multi. Now it is fine. And in the same way we can use for the division. So I think you go to the detail how we can create everything. for division. Okay, so the CLC and clear, semicolon, values. E is equal to, I have is D divided by A, D divided by C. Okay, and display function A, and then execute. So the value is 2. So here you can see that I use here the script file, and by using the percentage we can divide this script file into the subsections. Okay, and which section you want to run, according to that your cursor must be in that particular section. Okay, and if you want to run this section, then you will go to this place, press here, so only this section will execute. And sometimes if you need to run this section, come this at this place and then press here. Okay, so this is the way to create the script file. And the beauty of this script file is that all the statement which you write here will be available for future access. You can see that the file which we create with the name of basic operation is available inside my current directory. Okay, double click on it, this will open, and you can see all the statement which we execute are available here for the future use. Okay, so thank you for attending lectures today on the basic operations and arithmetic in the MATLAB. I hope this session is helpful you to understand how simple and powerful MATLAB can be. It comes to handling numbers and performing computations. In the next lecture, we will move to step further and explore working with variable and constant, an essential topic that forms the backbone of the programming in MATLAB. Until then, keep practicing, stay curious, and don't forget to subscribe the channel so you are notified as soon as the next lecture is uploaded. Thank you.